Alright, so this problem requires us to find the current across the 2.4 ohms resistor, which is this, and specify the theorem that we should use, Thevenin's theorem, right? Thevenin's theorem. So as such, if we are doing something like that, means we'll need VTH, right? And then we'll need RTH, right? Right. When it comes to these two things, most of the time the one that is the easiest to find will be the RTH, right? So we'll try and find that first. Before we do that, whenever we are using Thevenin's theorem, what happens is that we we should be able to remove this one out, right, and put the Thevenin's voltage there, and then do that. So this here is the circuit we get when we remove the resistor of interest, right, and place we do an open circuit there and place the Thevenin's voltage there, right? All right. So when we have that, now we should be able, because we are the next what we are following is that we need RTH and VTH, right? But we are trying to find RTH first, right? So there's the process that we are going through. So we open circuit, and now we are trying to find the Thevenin's resistance. We can't find it directly. Why? Because when it comes to these three here, we don't know whether they are in series or parallel, right? And clearly we know these three are in delta configuration, right? Where we have this, and then this, right? So we can't do it directly. So a way to do this is that we transform the delta to star, which we end up getting a circuit, the resistor, an equivalent resistance system in this way. Yes, so we introduce it like this, right, which is all simple. But then when we simplify that and remove the delta, we end up getting something like this, right? So we are still in the simplification process, redrawing the circuit, right? At times, if you really understand it, you shouldn't be redrawing everything shouldn't be a way, because you'll be able to see what's actually happening, right? So then, after we've done that, clearly we can see that these two here are in series, so we can add those up, right? When we add those up, we get a 6 like this, right? We get a 6 like this, right? And we know that clearly these two here too are in series as well, right? So these two are in series, so we can add them up, right? So basically the circuit has been complicated, but it can be simplified. So when we add these two up, we get this 6 here, and then when we get the 6 here, we can also find these two in series too, and we get a 4, right? So there's a 4, there's a 6, right? And we can see clearly that the 4 and the 6 are in parallel. We've discussed already, and parallel because you can move across them, right, without passing through any other element aside them, right? So they are parallel, right? Because they are parallel, we end up getting something like this, right? 4 and 6. So let's see. We'll have to find the value for that one. So the problem specifies that we should use Thevenin, right? So we are trying to find the RTH first. When we find the RTH, we move on to find the VTH, right? So we've simplified the circuit too, because we are trying to find RTH. We simplified it this much, so we'll be able to find it easily, right? So we've broken it down step by step to actually see what's happening, right? So here we have RTH, we have a 4 in parallel with 6. We don't have the value for that, so that's product of a sum 4 plus 6, right? And that gives us a 2 point. So that gives us a value of 2.4 for this, right? So we end up getting here we get 2.4 for this. So this here is equal to 2.4, right, ohms. And when we add this 2.4 ohms to this one here, we get 3.4, right? So this 2.4 here plus 1 gives us a 3.4 ohms, which is basically the Thevenin resistance that we're looking for, right? So 3.4 ohms, right? So that means that our RTH, Thevenin's resistance, is equal to 3.4 ohms, right? So now that we found this, because when we started, our aim was to find RTH and what VTH, because we are using Thevenin's method. So when we are trying to find, now we are done with the RT. So when we are trying to find the VTH, there are two ways that we can go about this. Either we use the original delta that we're given, or we use the star, right, that we transform to get when we're trying to find RTH, right? We're going to try both. So if we are trying to use the delta, right, so now we are using the delta. So let's take this out, come back to that, right? So we are using the delta now. So now we are going to assign the loop so we can see clearly what's happening. So A let's see, this is this is A, B, this is C, this is D, this is G, this is H, this is I. Let's make this J, right? Right. So now, meaning that you have to assign, let's assign the current as well, right? The current will appear this way, right? So this is how the current will appear. Let's see. So that will mean that we have the current coming from this main one here is I. This is something. This one here is I, right? And then that same current still I here. But when it gets to this side, it will have to split, right? So if I1 passes through this side here, right? The current that will pass through here will be I, doesn't mean be I minus the I1 that passed through the other side, right? And when it comes to this I1 here, when it's flowing, right, when it gets here, it will sense an open circuit here. It's not going to pass there, right? All of it will flow through the side. So this same I is here, right? Yeah. Oh, this is I1, right? So this same I1 is here, right? And this is minus the I1 at the top, right? So I minus I1. So that will mean that when this I1 gets to meet this I minus I1 here, only I will pass here, right? Which makes sense because we started with I, have to end with I. So the same current that's passing through coming here as an I, right? So now that we have this, we are going to write equations out of them and see what we get. Right? So if you consider this loop, let's see. So we consider A, B, C, G, H, I, J, E. The loop is just for us to see what's happening, right? So if you consider this one, we are using Kirchhoff's voltage law. That means we have 10, right? We are choosing this direction for now. Now we have 10, right? The next resistance we encounter is a 3, right? And the current, that one too, is in the same direction. So let's see, this current is like this, right? Current flowing through this one to this way. So everything is a plus plus, right? Current flowing through this 3 ohm here, right, is what we have to be. So let's see, 3 ohm, and we have I minus I1, right? Right. The next one we encounter because of the loop we've chosen. So A, B, C, G, right? And now we are between G and H, the G and H branch. So that will mean that we are considering the 5. So plus, let's put it here. So plus 5, the current flowing through that is just I, right? Alright. And then the current flowing through the last 3, which is this one here, this. So for the 3 as well, it's I, right? Yes, I. So we have I. So this one equation. So looking at it, we have 2 variables, which is I and then I1, right? So meaning we need another equation to be able to find this I and I1, right? In the first place, because we actually need it because we'll be able to use that to find the VTH, right? So let's see. The next equation we can use to find that. Right? So considering what we have here, we can also use this loop as well. We can use a CDH, CDG. So we are using CDDG, C. This is a loop we are using. So look at that variable, CDG, right? Okay. So we've chosen to move in this direction, right? Within that loop that we just selected, which is a CDG. So what will happen is that we'll have 3I, so that will be 3. Okay, because you are doing VTH, our V is 0. There's no voltage source within that particular loop, right? So current passing through the 3 ohm is I. So we have 3I in the direction we've chosen, 3I, 3I1, right? And then we have another 3I1, right? Plus 3I1. What do we have again? We have another 3, but the direction this time is opposite, right? So clearly see that this is in this direction, this 2 is in this direction, but this is in opposite direction to where we are going. So that's minus, right? So we have minus 3, and then that's I minus I1, right? So simplifying this, it gives us 0 is equal to let's see, this is 3. Okay, so let's see. So this gives us 6. Let's see. This is a 6i1 for the top side, and then we have a minus 3i, right, and then plus 3i1, right. So we're now getting 0 is equal to 6 plus 3, that gives us a 9, so that's 9i1, right. Just this plus this here, and then we have a minus, right, minus this one, minus 3i. So now we have this one equation. So let's make this equation 2, and this top one here is equation 1, but let's rearrange that to make it simple. So let's see. So the case is that you always have to be able to read through the diagram and simplify if you must, right? If you want to see things clearly. So 10 is equal to this is 5 plus 3, that's 8i, right? And then when we take we add another 3, becomes, which is this one right here. We add this 3, it becomes 12, right? Okay, so this 5 plus 3, that plus 3 is 8, plus this 3 gives us 11, right? So 11i, right? And then we have minus 3i1. So let's see what we are getting for this. This is another equation. So let's make this 1. So let's see. 2 variables, 2 equations, right? 2 unknowns. So let's see what we are getting for that one. Okay. So we've arranged everything already. So let's see. The first equation we have, so looking at how it is, the constants on one side, right? So the first equation we are making I. Let's write this out. So we are making I x, and we are making I1 to be y, right? So let's see. From equation 1, we have I to be 11, right? And then we have y to be minus 3. And then we have our constant to be 10, right? Equation 2, we have our I to be what? Equation 3, let's see, there's something that we've missed. I1 minus 3, there should be just I, there's no I1, right? So I is minus 3, I1 is 9, and we have our constant to be 0. So this gives us I1 as 1 amperes, and then Y, which is our I is 1 amperes, and our I1 is 1 on 3 amperes, right? And because of how we've done it, looking at the labeling, we said I is what we started with, right? That's what is coming from the voltage source, which is here. So as such, we clearly know that I is basically the total current, right? The total current, I total. Yeah. Okay. So now that we have this current, we can try, and the next will be to find the VT, because we consider let's see, let's choose our direction to be, let's choose our direction for the VTH. Let's choose down, right? So if you choose a direction and then you end up getting negative in the end, means that the direction is actually in the opposite of what you've chosen, right? So now we are considering CH because of direction. We are considering DHJ, right? Not find our VTH, right? So considering DHJ. So look DHJ D. That you're trying to find, right? So from that we know that VTH. We know VTH will be, so know our VTH will be, let's see, Let's consider the direction very, very well. Very important. Looking at the current passing through the 5 ohm, we know it's in opposite to where we are going, right? So that's 5 times minus I, right? So VTH is equal to 5 into bracket minus I, right? And then we are still moving here. The current passing through this I, the 3 ohm resistor, which is this. Oops. The current passing through the 3 ohm here, right? So we see it well. Okay, which is the I1, right? Current passing through this one, this one as well, right? So we've seen the direction here, right? It's also in the opposite direction to what we've chosen, so that will be negative, right? Negative, right? Yeah, I1, so that's negative, so that's minus, that's 3 times minus I1, so we have plus 3 into bracket minus I1, right? Let's go and confirm. Yeah, so because this I1 here, this was actually coming to flow here, so it's still I1, right? We have I1. So now that we have this, we have the values for both, we can find our VT, right? So let's see what we are getting using this method. So VTH will be 5 into bracket minus I. No, I is 1, so minus 1. Then we have plus 3 into brackets minus, and then we have I1. And we have I1 to be 1 on 3. So that's 1 on 3. Right. And that gives us a VTH of what? Minus 6, right, volts, right? And as we said, because we chose that direction and we haven't the VTH here as minus, means that the actual direction of the VTH, right, or the Thevenin's voltage, opposite direction to what we've chosen, right? So that will mean that this direction that we've chosen here must be reversed. But then don't change it. If you are drawing it in your diagram or in anything, don't change it. Let it be as how you did it. So it will relate to the values that you are getting, right? So to relate to the values you are getting, how you went through the whole process, right? Yeah. So this shouldn't be changed. Shouldn't be changing. If you are asked to draw a diagram, it shouldn't change. It should still remain here to show that there's the direction that you choose and there's the value you are getting, right? Okay. So now we've seen clearly how to do it using the delta what's the name? The delta diagram that was given in the original question, right? So now we are going to go through the process of using the star to actually find what's happening. So let's see. Let's give space for this. But then if you are good with one, it's fine. But then it's important you understand what's happening, right? And even if you are asked to use a particular method, if it's specified, then you know what to do. If it's not specified, you just know that you have options, right? Different ways to go about the same question. Now to get to the actual answer, right? Yeah, so that's what we are doing here. This is question 1. So now let's play this up. So now we are done with this, the delta. So we are going to cross that out. So we are done with this. And then we know the answer we are getting. So we are done with this. So now we are trying to use the delta, the star, to solve and get the answer we are getting using the delta, right? So now let's see. So then again, we are going to assign the loops and then the current as well, right? So let's see. Let's clean this one so it doesn't interfere. Okay. So that means that let's say we have A here and we have B. Let's zoom in. Okay. Okay. So we have B here and we have C. We have D, right? And we have E, right? We have F. We have G. The lettering is just for us to be able to label and then pinpoint what we are talking about, right? You don't necessarily have to write it. Someone somewhere looking at this should be able to see what's happening. Then again, we are choosing our VTH to be in that direction. Or should we reverse it? Well, let's reverse it for no secret reasons. So now we are choosing it this way. Then that will mean that whatever it is that you do, you have to comply to what you've chosen. Just for us to see what's happening. I think it can be given to you and you have to follow. But if it's not given, you are free to use whatever one you want. So let's see. seeing what's happening here, now let's assign our current. That would mean that the current coming from here is I, right? The current flowing through this 1 ohm here is still I, right? Okay. When it gets to this side, right, it will sense that there's an open circuit here, right? Because of this VT8 open side, it will not pass there. So that will mean that the whole I current will pass through this side. The whole I will pass through this 1 ohm, right? The whole I current will pass through this 5 ohm. That's what we're saying, right? That will mean that you still come and get the I current passing through this side again. So looking at this one is even much more clearer to see, right? So we can choose the loop A, B, F, E, G, H. So let's write that out, right? So let's see. So you have to decide which one works for you and choose that. So here we are choosing the loop. Let's see, A, B, F, D, E. Right. So you can follow where we are going. G, H, and E. So this is the loop we've chosen. Right. This is the loop we've chosen. So look at it very well and see what's happening. Right. Considering all that we have here, mean that if you are using Kirchhoff's voltage law, the only voltage within that side is the 10 volts, right? Okay, so now we are following. We are moving this direction. We get here, we have the 1 ohm, right? And the current flowing through it is I. So 1 ohm, current flowing through it is I, right? Then when we consider this, we still move here and we come to this side, right? That's between B and F. We have 1 ohm, right? So plus 1 ohm, and the current flowing through it is still I, right? And now we are here. We are moving between, we're moving from F to D, which is we have a resistor there to be 5, right? So that's 5, right? And then the current flowing through it is still I, right? Still I, still I, right? Now, so we are moving from that D, E, F, right? D, E, G, right? So from G to H, the to where we started, which is the H, right? Yeah, H before we get to E, right? Yeah, so we started from E. So to get to the H, let's see what's happening. That's the only resistance there is 3, right? So that's 3 ohms. And the current flowing through it is what? Still I. So very clearly we can find what's happening, right? So that would mean that we have 10 is equal to this plus this plus this. That's 3 plus. Clearly, there's something you can look at it and tell the answer, right? But what of if you're under pressure, is you can get things confused up. So it's easier, it's better for you to actually point it so you can focus your energy on better things. So or much more on clear things. So 5, 3. What do we have again? We have 1. What do we have again? We have another 1. And that gives us 10. Right? So that will mean that we have 10, which is equal to 10 and 10I. That will mean that I is equal to 1 amperes, which is what we have clearly, which is the same as the I total. I total, right? I total. So this one gives you the I directly, right? So now that we have this, we can move on and then find what's actually happening, find the VTH, right? So if we are considering the VTH, what will mean that the loop that we are considering will be, let's see, depending on the direction of the VTH that we have, that will be DCBFD, right? So that's DCBFD, right? Just you can confirm if written the right there. DCBFD, right? Mean that we have so let's see VTH first, right? VTH. Okay, so VTH. Those are the loop we've chosen, right? Okay, so let's see. And then we have when we consider that clearly we know that look at this very well. When we started, right? Once the side is short circuited, we have an open circuit here, right? When the current is flowing through this side, we didn't have any current flowing through this one, right? So meaning that there's no current flowing through that resistor there because of how the star and how we have it here, right? So meaning that one is taken out of the equation, right? So we started from C, right? D, C, B, F. Sorry. So D, C, B, F, and back to D, right? So let's see. So that's the direction in which we are going. Okay. So now we know what we are doing. VTH, there's no current through this one, so it's taken out because we need V is equal to I or something, right? And there's a current flowing through this one here, I. So we have I and then resistor of 1. So let's see. So resistance is 1, and then I, right? Oh, just I, not I1, just I. Plus, let's see, go back to it. We've considered this, now we are here. And the current flowing through this 5 is so the I, right? So that's 5I. 5I, that's 5 times I. So that will mean clearly, looking at this, VTH is equal to 6 volts, right? Yeah, 6 volts. So VTH is equal to, let's see, I is 1. So we end up getting 1 here. I is 1, right? Plus I is still 1, 5. So we end up getting VTH equal to 6 volts. Clearly, this is what we have, right? 6 volts. Right? And looking at what we know about the Thevenin, mean that we can simplify the diagram to the of something of this sort. Right? That will mean that the simplified circuit will have, let's see, the VTH will be, so VTH will be here. We have the current, the resistance here. So the VTH will be here. We have the Thevenin resistance. We have the elements of interest somewhere here, right? So let's put them in. Now we are simplifying the whole. We found all the values that we need. We found RTH, we found VTH. We are simplifying it to get what we are looking for, right? So we have this, and then we have this, and our elements of interest will be here, right? So our VTH is here. Let's have VTH. We know the value for that already, 6, right? And then effective resistance, which is RTH, what we got 3.4 or so, right? Yeah, 3.4. So that's our RTH. Right, so our RTH, and then our element of interest will be here. So let's put it here, RTH. And then our element of interest is also a resistor, which is a 2.4, right? Let's go back to the original problem. Yes, 2.4 ohms, right? So we have that as well. So our interest is to find the current, right? Which was current, right? Current through the 2.4 ohm resistor. Let's see. Yeah, the current through the 2.4 ohm resistor. Right? So yeah. So we have all the values we need. We know this is equal to 6. This is equal to 6 volts, and this is equal to 3.4 ohms, and then this one here, which is our interest, let's see, is equal to 2.4 ohms. That's 2.4, right? Let's check to confirm. 2.4 is 2.4. Right. So now that we have this, based on the Thevenin's theorem, we've simplified the whole diagram to this. That will mean that we have a V, the whole equation, as we've said so far, is equal to V is equal to I, right? And if you're trying to find the current through this, we know the current supplied here, right? I will pass through this and this, right? So this and this are in series, so the current passing through them is the same. So what we'll do is that we have to find the R, right? Considering the circuit, we have to find total R, which we have to be the total R, and then the VT that the voltage that we use is VTH, right? So that means that the current through the 2.4 ohm resistor, right? So current through the 2.4 ohm, right, is equal to VTH, because the same current is passing through the RTH and then the 2.4 ohm, right? They are in series, the same current. Yeah. So that will be VTH on R total, right? And we know R total is the same as 3.4, right, which is the RTH plus 2.4. So let's write this out so we see clearly what's happening. So 3.4. Right, so that's what we have, right? Oh, I wrote RTH. RTH. Okay, RTH, right? So clearly we can find the current through that one. So let's see. So the whole thing VTH, we have that to be 6, right? So that's 6 on this was 3.4 and this is 2.4, right? So that's 6 on 3.4 plus 2.4, right? And that gives us 30 ohm. The current through the 2.4 ohm resistor to be 30 on 29, depending on what's given. We have to specify, if not in fraction, they'll specify the number of decimal places in the instruction, right? Or if you not specify, just consider 4dp and be free, right? So that gives us about 1.0345 amperes, right? Yeah, so that's it. The current in the 1.2 ohm resist 2.4 ohm resistor, right? So that's this. Yeah, so that's it.